Okay, dear viewers, you are welcome again to this wonderful lesson, and we are going to be looking at benzene and its derivatives, and this is lesson 3. Before I go ahead, I want to assure you that amongst other recorded lessons include carbonyl compounds, so you can subscribe to the same channel, or you can subscribe to my channel and watch those other videos plus other areas like physical chemistry by the same person. I'm hyperchemist from Gaza High School, and this is my WhatsApp in case you want to reach out to me as a person, and this is the code in case you are from a different state. Basically, we are going to look at something that maybe I had forgotten in the second video yesterday, and this is identification of a functional group in benzene. Yeah, so basically, I want to begin with identification of a functional group. How do we identify a functional group of benzene? Identification of functional group in benzene. Basically, yesterday I showed you how we can distinguish benzene from cyclohexane. And basically, you need to know that the functional group in benzene is simply the phenyl group. So the functional group itself is a phenyl group. So when we talk about the functional group of benzene, look at it as a phenyl group. And a phenyl group is the same as C6H5. This is my phenyl group. So how do we identify it? We can identify it by testing benzene with bromine, or by reacting benzene with bromine in presence of aluminum chloride, as I said. So basically, to identify this phenyl group, we test, or we react benzene with bromine in presence of aluminum chloride. In terms of aluminum chloride. And yesterday I told you that the observation that we take here, we shall observe that a reddish brown solution turns colorless. So here basically a reddish brown solution turns colorless. So this is how best you can identify the functional group in benzene, or the phenyl group. Basically, we treat benzene with the bromine in presence of aluminum chloride, and observation of a reddish brown solution turning colorless will tell us that yes, it was a phenyl group in this substance. Now from here, we are going to look at the uses of benzene, and under uses of benzene, we shall look at a wide application, yeah, of benzene, which involves synthesis of some compounds. Then after this, we shall look at the derivatives of benzene in the same video, and then in an independent or separate video, we shall look at methyl benzene, or what we call toluene. So before we go further, before we go to methyl benzene, let's first summarize together the uses of benzene. So uses of benzene, this will involve synthesis. So we shall have the uses of benzene. And basically the first use, it will be benzene can be used in making plastics. Can use it to make plastics. For example, you can use benzene to make a polymer called polystyrene or polyphenyl ethene. So basically, it is converted to phenyl ethene, actually to polyphenyl ethene. Okay, let's first say it is converted to phenyl ethene. It's converted to phenyl ethene, which is used to make, polyphenyl ethene, to make polyphenyl ethene, and this polyphenyl ethene is a polymer, and this polymer one can call it polystyrene. Now, basically, I want to show you how we use benzene to form polystyrene. One, I want you to know that since this is a polymer of ethene, because we've seen that it is polyphenyl ethene, how do we form ethene, polyphenyl? We need first form phenyl ethene. And to form phenyl ethene, this one being an alkene, alkenes are obtained from alcohols. So we want to see how does benzene help us get an alcohol? Meaning we need first form a ketone, and you know that by reduction of ketones, we form alcohols, because alcohols can be oxidized to ketones. Those are secondary alcohols, meaning that ketones can also be reduced to alcohols. Yeah. So basically, we get benzene. So from benzene, we are going to first form phenylethanone. So basically here, we are going to carry out Friedel-Crafts acylation, CH3, CO, Cl in presence of a halogen carrier. It can be aluminum chloride, and this will give us a ketone here. We shall form a ketone. So after you formed a ketone, we saw this mechanism, meaning one should be able to outline this mechanism. Now this is a ketone, but ketones, like how aliphatic alcohols behave, when you reduce a ketone by using lithium tetrahydroaluminate, yeah, use lithium aluminum hydride, or one can call it lithium tetrahydroaluminate in presence of dry ether. This is H4. In presence of dry ether, this one is going to be reduced to an alcohol. Yeah, so you're going to form an alcohol. So this is I'll have HO for an alcohol, then I'll have C, H, then CH3. Now this alcohol is going to be, we are going to carry out elimination reaction, or we are going to use conch sulfuric acid. That is a common reaction to most of us. So we're going to carry out, we are going to react it with conch sulfuric acid. So react this with conch sulfuric acid. At a temperature of 180 degrees Celsius. This is going to be converted to an alkene, and this is phenyl ethene that we have been looking for. We are going to get phenyl ethene. So to get phenyl ethene, this will be C double bond CH2. Then we shall have H here. Now, after you formed this one is going to be treated with a polymer. So we are going to treat this with the an organic peroxide, and basically we use dibenzyl peroxide, dibenzyl peroxide, and we heat between 85 to 100 degrees Celsius, and this will form for us polystyrene. So polystyrene, this is a polymer, and it's going to be HC, then CH2. This is our polymer. And now, instead of using, okay, because in some books you'll be meeting this as the ROOR, organic peroxide. At some, if you don't want stress, you can use ROOR. But please, if you are a good chemist, if you want to be a good chemist, you can take it through here. You will be very, very, very fine. So you first carry out acylation to form a ketone, then you reduce a ketone to form an alcohol, then you carry out elimination, you form an alkene, then from an alkene you add an organic peroxide at 85 to 100, you form a polymer, and this polymer is what you call polystyrene. There is an alternative. Because you can as well get this phenylethene without you first forming this compound. Yeah, without you first forming this ketone. So alternatively, what we can do still, you'll get benzene. The alternative method, you'll get benzene, and you first alkylate. You can use ethene, H2C, double bond, CH2, aluminium chloride catalyst, as we saw. So this one will first form for you this. So we shall have CH2, CH3. Now, here we use a rare compound, or we use a rare mixture to convert it to phenylethene. Yeah, those of you who might be using textbooks, you might have seen that to convert this to phenylethene, you use a mixture of iron 3 oxide and chromium 3 oxide at a temperature of 650 degrees Celsius. So this will lead to the formation of phenylethene. Then now, after forming phenylethene, you add your dibenzyl peroxide, at specified temperature of 85 to 100 degrees Celsius, and this will give you polystyrene. As simple as this. So that's the first use. Then the second use is we can still use benzene. We can convert benzene to cyclohexane. That one we saw it yesterday, and this is a very, very important substance, because cyclohexane is an intermediate in manufacture of nylon. So still we can use it to get cyclohexane. And how do we get cyclohexane? By getting benzene. If you get benzene and you carry out hydrogenation using hydrogen in nickel at 150 degrees Celsius, you will form a very useful intermediate in formation or in a manufacture of nylon, And this intermediate is what we call cyclohexane. So basically, those are the first two uses. Now, another use, very, very important use, we can use benzene in making phenyl through the cumene process. So basically, we can use benzene, the second major use. We can use benzene in the formation of phenyl or preparation of phenyl. We can use it to prepare phenyl. Preparation of phenyl via or through the cumene process. So we want to see how the cumene process proceeds. Now, basically, you can use the cumene process in these various ways. One, we first have benzene. We shall first have benzene. We first carry out alkylation using propene. So we shall first carry out alkylation using propene, of which we outlined the mechanism yesterday. So it will be CH3CH, double bond, then CH2, using aluminum chloride catalyst. So this alkylation will lead, when you alkylate, you will form a compound known as 1-methylbenzene or a cumene. You first form a cumene. So this cumene, basically, since we are alkylating, we shall have this CH, and then, of course, this will be CH3 after the reaction here. So we shall have CH, CH3, CH3. Then from this, after having formed this cumene, we add oxygen. Now, after you have formed oxygen, what we are doing, we are adding oxygen to oxidize this cumene to form cumene hydroperoxide. You form what we call cumene hydroperoxide. And this cumene hydroperoxide can be written in various ways, in very, very, very various ways. But the easiest, it's just a matter of on this C to attach these two oxygens so that you have COO, then H, then you attach the two alkyl groups, the methyl group CH3, CH3. This is what we call cumene hydroperoxide. Now, this cumene hydroperoxide, you can treat it with the warm dilute sulfuric acid. So you're going to treat this with warm dilute sulfuric acid. And because it's a dilute, we are going to add water. And then you say sulfuric acid. And this reaction will lead to the formation of phenyl as a major product. You're going to form phenyl as a major product, that is benzene with OH attached. And then after removing this phenyl with OH, we are left with the CO, CH3, CH3, and that is propanone. So we shall have propanone, CH3, CO, CH3. So this is what we call the cumene process. However, instead of the vapor phase, yeah, still you can alkylate benzene using propene in liquid phase, but in this case, aluminum chloride can be used as a catalyst. So you can use as many ways as possible to get this cumene. Still, one can use to get propene. I can use, sorry, to get cumene. Still, I can use propene. That is CH3, CH, double bond, CH2. I can use aluminum catalyst, aluminum chloride catalyst. Is a catalyst. I can use it at 250 degrees Celsius and 30 atmospheres. So still you'll get your cumene. You oxidize it, you get cumene hydroperoxide, then you treat it with the dilute sulfuric acid. and you get your final answer. So those are the two major uses of benzene. There are others, but these are the two major uses that we can use in the lab to prepare, to get some derivatives which are quite much important. So still in the same video, allow me talk about the derivatives of benzene. Simply, I'm going to summarize for you the derivatives of benzene. We name them together, and then in our next video, we come to look at methylbenzene in particular. So let's summarize the derivatives of benzene. There are too many, but I'm going to put only those ones which are in our scope. So derivatives of benzene. Now, these derivatives of benzene, one, they are different because you can get them using different routes, but allow me remind you of the conditions. So we have benzene here, but we are going to use it to get very many different substances. I will use the one of the ring, but one can use the one of the bonds. Yeah. So one, I can add iodomethane one can use iodomethane, one you can use chloromethane, one can use bromomethane in presence of any halogen carrier. And this one will be, since this is alkylation, you'll be getting methylbenzene. However, there are other different ways how you can get this methylbenzene. Still, one would use one can first take it to bromobenzene, then bromobenzene. Anyway, we shall look at the synthesis when we go to methylbenzene in particular. We are going to bring it at that point. Yeah, shall get it. So this is methylbenzene. Let me take it like that. Then two, you can as well use a different reagent. For example, one can use chloroethane, that is CH3, CH2, Cl, in presence of a halogen carrier steel, aluminum chloride. You'll be getting, we are going to name them later. So now let's just form the product to be CH2, CH3, CH2, CH3. Still, you can carry out, I'm giving a summary, you can carry out acylation. So acylation, that is where we use an acyl chloride, that is CH3, maybe COCl, in terms of a halogen carrier, maybe aluminum chloride, and this gives the phenyl ethanol, COCH3. Then still, you can carry out nitration. And for nitration, we said that you must use concentrated equimolar solutions of concentrated nitric acid and concentrated sulfuric acid at the temperature 55 to 60 degrees Celsius, and this will be giving you nitrobenzene. Yeah, this will be giving you nitrobenzene. We shall find out that these derivatives are quite much employed in other areas. Then now you can as well use the conc sulfuric acid or fuming sulfuric acid. Let me use fuming sulfuric acid. If you use fuming sulfuric acid at a temperature of 35 to 50 degrees Celsius, you'll be forming benzene sulfonic acid as another derivative. Benzene sulfonic acid. Then now still, you can carry out halogenation. If you carry out halogenation, for example, using chlorine in aluminum chloride, you'll be forming what we call chlorobenzene. Still, you can get bromobenzene by adding bromine In presence of halogen carrier, maybe iron 3 bromide, but I told you that you can use iron, then you first form the halogen carrier by yourself. So this will give you bromobenzene. But I told you that halogenation of iodine with iodine is not possible with halogen carriers because of the reasons we saw yesterday. So now this time around, if you want to get iodobenzene, to remind you, to get iodobenzene, we use iodine, but we say that we use it in conch, nitric acid, and we reflux. So conch, nitric acid, and we reflux. So someone who puts iodine in a halogen carrier, that person will do us bad. That person will be doing us bad. Now, from this situation, from these situations, these two derivatives, these first two derivatives, because this one, we are going to see the substitution with the methyl group when we look at methylbenzene. The moment you use a strong oxidizing agent, you will be converting these direct to a carboxylic acid. So for example, if you use permanganate iron, or one can call it manganate 7 ions, which are acidified, and you heat, if you do that, you will be able to get what we call benzoic acid. This is another derivative. We have seen what this ketone does. You reduce it to alcohol, you eliminate alcohol to an alkene, you treat it with the peroxide, you form polystyrene or polyphenyl ethene. Now, what we did not talk about this was this. We can get another derivative of benzene by treating nitrobenzene with the two reagents. One, you can treat it with tin in conch HCl. Two, you can treat it with the aqueous sodium hydroxide at 60 degrees Celsius, or you can say heat. You can say heat, and this will be giving you aminobenzene, or what we call aniline. Then you can treat this benzene sulfonic acid. You can take it to phenyl. You can take it to phenyl. How? You can treat this with the aqueous sodium hydroxide so that you form SO3 Na. Then you treat it with the solid sodium hydroxide at 360 degrees. You'll be getting a phenoxide, sodium phenoxide. Then from sodium phenoxide, you can treat it with the dilute HCl, and automatically this will be giving you phenol. Then all these ones, the chlorobenzene, bromobenzene, and iodobenzene, if you treat them with the steam, you can find yourself there with them. If you treat them with the steam in silicon at 450 degrees Celsius. So this is a summary of some of the few derivatives of benzene that maybe we can talk about for now. So now we are going to see how we can name some of them. The ones which are included here, we are going to name them directly from here. For example, this is what we call methyl benzene, the IUPAC name. I'm giving the IUPAC names. This is methyl benzene. Yeah. This is ethyl benzene. Yeah. This is ethyl benzene. Then you can also name this as phenylethanone. This is phenylethanone. Yeah. This is benzoic acid. This is nitrobenzene. This is aminobenzene. This is benzene sulfonic acid. This is phenyl, or one can call it hydroxybenzene. This is chlorobenzene. This is bromobenzene. This is iodobenzene. Maybe the ones that I've not talked about, the ones that I haven't talked about, I can have them written. Maybe if you have something like this, if you have this derivative, there is an O in between. We talked about it yesterday in some mechanism, actually in some video. One can call it phenoxybenzene. This phenoxybenzene. We can also have another derivative. You can also have this derivative with a CHO. This is the functional group for an aldehyde. One can call this one benzaldehyde. Benzaldehyde. We call it benzaldehyde. We are going to look at benzaldehyde in detail. When you go to methylbenzene, this can be called benzaldehyde. One can call it benzene carbaldehyde. Benzene carbaldehyde. Then we've gotten a diazonium salt. And you have N, triple bond, N, Cl minus. This is called benzene diazonium chloride. Benzene. It's a one word, don't leave space. Benzene diazonium chloride. Then we can also have this, and this is what we call phenylethine. Phenylethine, one word, don't leave space, one word, phenylethine. You can also have this with the CH2OH, and it's called phenylmethanol, one word, phenylmethanol. That is phenylmethanol. You can as well have CH, CH3. The OH is attached on the first carbon, so this is one phenylethanol. You can also have this. This is 2-phenylethanol. So there are very many derivatives, but I'm not going to cover all at once because it is not possible. Now, let's meet in our other video, which is my fourth lesson, and that fourth lesson will be introducing us to methylbenzene, or what we call taurine. Let's meet there. Be blessed.